So here we're asked to determine the graph of cos x plus pi over 6 minus 4. Now, in order to do these types of questions, it's usually really useful to understand what the base equation of y equals cos x looks like. Now, I have other videos on my channel that go over simple tricks on, not really tricks, but simple tools and things to remember to graph a cos x equation. Now, cos x equation has a starting point. Okay, so a starting point at 0 and 1. And then we go down to pi over 2. We also have pi. So I'm using the quadrantal angles to make my simple graph here, and then 2 pi. And then you can really easily graph these things. So what is cos when cos is at pi over 2? Well, it's at 0. What is cos when it's at pi? Well, it's at -1. So I should put -1 here and 1. And then what is cos at 3 pi over 2? Well, it's 0 again. And then what is cos at when the angle is 2 pi? Well, it's 2 pi. Right? So we get a function that looks like this, and it would just repeat itself, right? It would go on forever and ever. Now, recognize again, this is going a little bit overboard in our review, but I'm simply getting these values from our quadrantal angles here and here. So remember our x coordinates on our unit circle tells us how to graph our cos x equation. Anyways, watch my video if you don't understand how I found that. Now we can use this to really visualize how to graph this equation, okay? Because we can see these as simply shifts applying to our base function cos x, right? So x plus 6, this guy is a phase shift pi over 6 units to the left. Remember, when a transformation occurs on the x coordinates, it's opposite. So we are moving left even though there's a positive here. Okay, that tells us we've moved to the left pi over 6 units. This guy is attached to our midline. So we have taken our entire graph of cos x and moved it down 4 units. So recognize on a regular cos x equation, we have our midline found right here, right? This is y equals 0. Well, now that new midline is found at y equaling -4. So we can start to graph this thing fairly easily. So we'll have -1, -2, -3, -4, and recognize the amplitude here stays the same. Okay, we have no stretch vertically to affect our amplitude, so our amplitude will still be 1 on our new equation. We're going to have our midline found at y equaling -4. Okay, so that's our midline. Now, what about our phase shift? How do we deal with that? Well, if you think about it, we're just moving all of these important points pi over 6 units to the left. So how about dealing with 0? Where does that new starting point go? Where does this starting point go? Well, 0 minus pi over 6, that equals -pi over 6. So our starting point will be found at -pi over 6. So we can graph that. Remember, our amplitude is still 1. So at pi over 6, we have now moved to this point. That's our new starting point. Okay, so we've moved pi over 6 units to the left. How about our point here? Where did our point go there? Well, it's on our midline, so we know we're going to plot it somewhere where y equals 4. But how do we figure out which way it moved and how far? Well, pi over 2, it moved pi over 6 units to the left. So we can multiply the top and the bottom by 3 to get common denominators. So 3 pi over 2, over 6 minus pi over 6. So that gives us 2 pi over 6. So now we have 2 pi over 6 being our point here. So this point, I'm going to put it as 0.1, correlates to this point, 0.1. Okay, and you can just keep repeating this method. This point, which is 0.2, where did that phase shift go? Well, it's going to be a minimum, so it's going to be found on the y equals -5 line because our amplitude is 1, okay? But where did this go? Well, 0.1, pi shifted pi over 6 units left. So let's get the same denominators. So multiply the top and the bottom by 6. So here we get 6 pi over 6 minus pi over 6. So that gives me 5 pi over 6. So now we have 5 pi over 6. And we are going to be found somewhere around here. So now we have another point of interest. Okay, so we're starting to create our curve a little bit better here. And we're going to repeat this process here. So now this is 0.2 that we found. What about 0.3? Well, remember, 3 pi over 2, which is here, that shifted over pi over 6 units left. So minus pi over 6, multiply the top and the bottom by 3 to get common denominators. So you get 9 pi over 6 minus pi over 6. So that will give me 7 pi over 6. So 7 pi over 6 is found here. Now the really nice part about doing this is you're going to notice a pattern occurring. Okay, our pattern is that we're going up by 3 pi over 6 increments. Okay, so recognize to get here, we've added 3 pi over 6. To get from this section to our unit here, oh, I messed up here. This should be 8 pi over 6. Sorry, 9 minus 1 is 8. So this is adding 3 pi over 6 again. Just to kind of prove it full and true, let's look at 2 pi over 6, so 0.4 here. Well, 0.4, 2 pi has moved pi over 6 units to the left. Again, let's get the common denominators. So this will give me now 12 pi over 6 minus pi over 6, which gives me 11 pi over 6. 11 pi over 6 will be found here. And recognize this point up here, which is our, I guess technically our 0.4, sorry, is at a maximum. So it'll be found at a maximum here. So 11 pi over 6 is going to be found at y equaling 3. And now we have created our first cycle of our graph. And you can continue this as long as you keep going up by 3 pi over 6 increments. So now this is add 3 pi over 6. So let's add 3 pi over 6 again. So here we will be given 14 pi over 6. And if we continue here, that'll be a midline point. So go down, and then we're going to add another 3 pi over 6, which will give me 17 pi over 6. And that will be a minimum point. So down here somewhere. Okay, and you can now realize that this is just going to continue on and on and on. And that's how we simply graph this equation by looking at our original cos x equation.